Imagine everything you know squeezed into a tiny space smaller than a pinhead. This was our universe billions of years ago. Then, bang! A massive explosion, the Big Bang, happened. It wasn't like a regular explosion with sound and fire, but a sudden expansion of space and time itself. Think of a balloon being inflated. As it gets bigger, the dots drawn on its surface move further apart. This is similar to how galaxies are moving away from each other in our expanding universe. The Big Bang was incredibly hot and dense. It's hard to imagine such extreme conditions. Over time, this hot, dense universe started to cool down and expand, much like the balloon as it inflates. As the universe cooled, things began to change. Energy transformed into particles, and particles began to interact, setting the stage for the formation of everything we see today. In the first few moments after the Big Bang, the universe was incredibly hot, like a giant cosmic soup. Temperatures were so high that atoms couldn't even exist yet. Instead, there were only tiny particles zooming around at incredible speeds. These weren't the particles we learn about in school, like protons and neutrons. These were even smaller, more fundamental particles like quarks and leptons. They interacted with each other constantly, colliding and transforming in a flurry of energy. As the universe expanded, it also cooled. This cooling was crucial because it allowed those tiny particles to start sticking together. This was the beginning of the formation of the first elements, the building blocks of everything we see around us. Imagine a dance floor filled with people moving incredibly fast. As the music slows down, people start to pair up and dance together. Similarly, as the universe cooled, those tiny particles started to combine, forming the first protons and neutrons. As the universe continued to cool, protons and neutrons, those building blocks of atoms, started to combine. This period is often called the era of nucleosynthesis, a fancy word for the formation of atomic nuclei. The first element to form was hydrogen, the simplest and most abundant element in the universe. It consists of just one proton and one electron. Some of the hydrogen then fused together to create helium, the second simplest element with two protons and two neutrons in its nucleus. These two elements, hydrogen and helium, made up almost all the matter in the early universe. It was like a giant cosmic cloud of these light elements, spread out over vast distances. However, this cloud wasn't perfectly smooth. There were tiny variations in density, places where matter was slightly more clumped together. These tiny clumps would eventually, under the influence of gravity, become the seeds of galaxies and stars. Gravity, the force that makes things fall down here on Earth, played a crucial role in shaping the universe. Even though those early clouds of hydrogen and helium were spread out, gravity started to pull them together. Imagine a giant game of cosmic billiards, with gravity acting as the invisible cue stick. Over millions of years, gravity drew these clouds of gas closer and closer, causing them to spin and collapse in on themselves. As these clouds collapsed, they got hotter and denser. Eventually, the pressure and temperature at the center of these collapsing clouds became so intense that nuclear fusion began. Hydrogen atoms were forced together, fusing to form helium and releasing enormous amounts of energy. And just like that, the first stars were born. These early stars were massive and short-lived, burning brightly for a few million years before exploding as supernovae. But their deaths were not in vain, for they scattered the seeds of heavier elements across the cosmos, paving the way for the formation of planets like our own. Section 5. From Dust to Disks, the Birth of Solar Systems. When massive stars exploded as supernovae, they didn't just scatter light elements like hydrogen and helium. They also created and dispersed heavier elements like carbon, oxygen, and iron, the very elements that make up planets and even ourselves. These heavier elements mixed with the surrounding gas and dust, enriching the interstellar medium. Over time, gravity began to work its magic once again, pulling this enriched material together into giant rotating clouds called molecular clouds. Within these swirling clouds, denser regions began to collapse under their own gravity, much like the process that formed the first stars. As these regions collapsed, they spun faster and faster, just like a spinning figure skater pulling their arms in. This spinning motion caused the cloud to flatten into a disk shape, with a protostar forming at the center, radiating heat and light. Surrounding this protostar was a swirling disk of gas and dust, the raw materials from which planets would eventually form. Section 6. A Dance of Gravity. Within the swirling disks of gas and dust surrounding young stars, a delicate dance of gravity and collisions began, leading to the formation of planets. This process, known as accretion, is a bit like cosmic dust bunnies forming under your bed, but on a much grander scale. Tiny grains of dust coated in ices and other elements collided with each other within the disk. If the collisions were gentle enough, the particles stuck together, held by electrostatic forces. Over time, these clumps grew larger, their gravitational pull increasing. As these clumps grew larger, they attracted even more particles, eventually forming planetesimals, small bodies a few kilometers across. These planetesimals continued to collide and merge like cosmic bumper cars, gradually building up into protoplanets, the precursors to full-fledged planets. The type of planet that formed depended on its location within the disk and the composition of the surrounding material. Close to the star, where temperatures were high, rocky planets like Earth formed. Further out, where it was colder, gas giants like Jupiter and Saturn accreted vast amounts of gas and ice. Section 7. Our Cosmic Address. Our planet Earth is a tiny speck of dust in the grand scheme of the cosmos. We are part of the solar system, a collection of 8 planets and countless smaller objects orbiting our sun, a star we affectionately call Sol. Our solar system resides in the Milky Way galaxy, a vast spiral galaxy containing billions of stars. And the Milky Way is just one of billions of galaxies that make up the observable universe. Our cosmic address is a humbling reminder of our place in the vastness of space and time. It underscores the interconnectedness of everything in the universe, from the smallest subatomic particle to the largest galaxy cluster. The elements that make up our bodies, the air we breathe and the ground we walk on, were all forged in the hearts of stars that lived and died long ago. We are, in a very real sense, stardust. Section 8. Looking back in time. Gazing up at the night sky is like looking back in time. Because light takes time to travel across vast cosmic distances, the light we see from distant stars and galaxies has been traveling for millions or even billions of years to reach us. Astronomers use powerful telescopes to observe this ancient light, piecing together clues about the early universe. One of the most important tools in their arsenal is the cosmic microwave background radiation, the faint afterglow of the Big Bang itself. By studying this faint glow, astronomers can learn about the conditions in the universe just a few 100,000 years after the Big Bang. They can measure the universe's expansion rate, its composition, and even test their theories about the fundamental laws of physics. These observations provide strong evidence to support the Big Bang theory and our understanding of how the universe evolved from a hot, dense state to the complex structures we see today. Section 9. The Universe, a never-ending story. The universe is not a static place but a dynamic and ever-evolving entity. Galaxies continue to move and interact, stars are born and die, and new planets may be forming around distant stars even as we speak. The ultimate fate of the universe is still a topic of debate among cosmologists. Will it continue to expand forever, growing colder and darker, or will it eventually collapse in on itself, in a big crunch, perhaps giving rise to a new cycle of creation? Whatever the future holds, one thing is certain: the universe is a place of endless wonder and discovery. As we continue to explore the cosmos, we are sure to uncover new mysteries and deepen our understanding of our place in the grand scheme of things. The story of the universe is a never-ending story, and we are privileged to be a part of it.